Find the sum to n terms of an arithmetico-geometric series. Let us begin. So here, in this problem, we are provided with a series. The first term is 1, followed by the next term, which is 3x. Next, we have the third term, which is 5x squared, followed by 7x cubed. So this keeps on going. Now, in order to find out the sum to n terms, we need the nth term. So that means our first task will be to find out the nth term of this series. Since it's an arithmetico-geometric series, so what we'll do? We will find out its corresponding arithmetic progression and geometric progression, because it's composed of two different progression. So the arithmetic progression of this particular series will be, so here we take the constant term from the first term, then we take the next constant term from the second term, then we take the constant 5 from the third term, followed by 7. So clearly this is an arithmetic progression whose first term is 1. The common difference will be 2. So that means the nth term of this arithmetic progression, that is going to be given by, we have the standard formula for it, the first term added to n minus 1 times the common difference d. So let's replace the value of a with the first term, we have 1, added to n minus 1 times the common difference, so that's 2. So we have 1 added to 2n minus 2, that will be equals to 2n minus 1. Fine. So here we have the nth term of the arithmetic progression. Similarly, we will find out the corresponding geometric progression. The geometric progression, what we'll take the first term as 1. Then we have the second term. So here the second term, we have a product of 3 and x, so we will only consider the variable x. In the third term, we're going to consider the variable x squared. And the fourth term, we will consider x cubed. So this keeps on going. So this is a geometric progression whose first term is 1, and the common ratio denoted by r, that's going to be equals to x. So we can easily define its nth term. So that's given by the formula a, the first term, multiplied to the common ratio raised to the power of n minus 1. So that's going to be equals to 1 multiplied to x raised to the power of n minus 1. Fine. So now we have the arithmetic progression as well as the geometric progression. I mean, we have found out their nth term. We are ready to find out the nth term of the arithmetico-geometric series. So we will take the nth term of the arithmetic progression, so that's 2n minus 1. And we're going to multiply it to the nth term of the geometric progression, so that's x raised to the power of n minus 1. So we have now the nth term of the arithmetic-geometric series. So that means we can now write the given series as 1 plus 3x plus 5x squared plus 7x cubed added to the rest of the terms. We're going to use one more term here, and we have the nth term, which is 2n minus 1 multiplied to x raised to the power of n minus 1. Fine. Now, this is the series that we are going to work it, and we're going to name this series as Sn. So we have Sn. This is the sum up to n terms. We'll have to find out its value. To find out the value, we need one more thing. We need the second last term. To find out the second last term, what to do? We just consider the nth term and here substitute n with n minus 1. So if we substitute n with n minus 1, then 2n minus 1, that's going to become 2 times n minus 1 minus 1. This will get multiplied to x raised to the power of n minus 1 minus 1. So when we simplify this, we're going to get 2n minus 3. So 2n minus 3, this would be multiplied to x raised to the power of n minus 2. So this is the second last term of the series. So let's use this value. So we have here 2n minus 3. This was going to get multiplied to x raised to the power of n minus 2. Right. So now we have defined the series. So we'll have to find out the sum. So what we'll do, in order to find out the sum of the series, so what we'll do, we're going to consider the common ratio of the geometric progression, which is x in our case, and we're going to multiply throughout with x. This is going to now give us x multiplied to Sn. This is going to be equals to, now 1 multiplied to x, so that's going to give us simply x. Added to, next we have 3x, the second term of the series. It's going to get multiplied with x to give us 3x squared. Then we have 5x squared getting multiplied with x, so that's going to give us 5x cubed. And this is going to go on till the second last term. So we have 2n minus 3 multiplied to x raised to the power of, now x multiplied with x raised to the power of n minus 2, that's simply x raised to the power of n minus 1. This is going to get added to 2n minus 1 times x raised to the power of n. Fine. So now we have two series. Now what we will do, we'll take the first series, which is Sn, and from here we're going to subtract x times the second series. This is going to be equals to, now let's do the subtraction. So we'll be left with 1. Now 3x minus x, that will be positive 2x. Added to 5x squared plus 3 minus 3x squared, that will be positive 2x squared. Then we have 7x cubed minus 5x cubed, that's going to be 2x cubed. This is going to go on. Now we will consider the last term of Sn, which is 2n minus 1 term x raised to the power of n minus 1. And from this term, we're going to subtract the second last term of xSn. So 2n minus 1 minus 2n minus 3, that's going to simply give us 2. So we have 2 multiplied to x raised to the power of n minus 1. And then we have the last term of xSn, so that's simply minus 2n minus 1 multiplied to x raised to the power of n. Okay, now what we'll do, on the left hand side, we're going to consider Sn as the common factor. So Sn is going to get multiplied to 1 minus x. This is going to be equals to 1 plus. Now we are going to combine 2x plus 2x squared plus 2x cubed. And what I mean by combining, what I mean here is that we will find the sum of these terms. Fine. Minus 2n minus 1 multiplied to x raised to the power of n. Fine. Let's compute the sum here. Now this is a geometric series. Clearly this is a geometric series whose first term, so this is the first term, that's a 2x. The common ratio r that can be obtained by dividing the second term with the first term. So 2x squared divided by 2, that's simply going to be x. And we know that the sum to n terms, that's given by the first term multiplied to 1 minus r raised to the power of n divided by 1 minus 1. So in our case, let's write it down. So we have here Sn multiplied to 1 minus x. This is going to be equals to 1 added to, now what's the first term? So that's 2x. 2x is now going to get multiplied to 1 minus the common ratio x. Now here we have to be slightly careful. Now the first term is not starting from 1, so that means in fact there are a total of n minus 1 terms. So there are not n terms, but there are a total of n minus 1 terms here. So we're going to raise x to the power of n minus 1, because that has to be the number of terms present in the series. Whole divided by 1 minus the common ratio, which is x in our case, minus the remaining term. We have 2n minus 1 times x raised to the power of n. Now we're going to divide throughout with 1 minus x, and that's going to give us Sn on the left hand side. We have Sn equals to 1 over 1 minus x added to 2 times x multiplied to 1 minus x raised to the power of n minus 1, whole divided by 1 minus x, but again we're dividing with 1 minus x, so this will become 1 minus x squared, minus 2n minus 1 times x raised to the power of n, whole divided by 1 minus x. So this is the final sum. This is the sum up to n terms of the Arithmetico-Geometric series, which is 1 plus 3x plus 5x squared plus 7x cubed and so on.